Strings are a very important part of programming. And so let's now learn about an easy way to build strings using something called template literals. And let's start by creating some new variables here about a person, and in this case about me, so that we can then concatenate them into one big string. And the birth year. Okay, and so let's now use these variables to build a string, something like, I'm Jonas, a 40 or 30-year-old teacher. So we're gonna then use this birth year to calculate the age, of course. So let's call that one simply Jonas. And as we already learned in one of the previous lectures, we can use the plus sign to concatenate strings. And so let's now start by doing that. So I want to write I'm, and here I'm seeing a problem. So when I want to use this single quote here for writing something like I'm or isn't, so basically when I need this symbol here, then I need to write the string itself using double quotes, okay? Because otherwise the single quote that I'm using here for I'm will finish the string. So I'm, and then I need a space, then the plus, and so here I'm saying I'm Jonas. And now I can actually use the single quotes. So what matters is that in each string, we start and finish with the same symbol, right? But both just create strings the same way. So right now we have I'm Jonas, comma, a, and now we want the age. So let's say a 30-year-old teacher. So we need another space here. And then let's actually calculate the age. So that's the current year. So let's put that here as well. And let's again say that the year is 2037. So plus year minus the birth year. Now, in order to make this work, we actually need to put this operation between parentheses. Like this. And so it will do the calculation first and then the concatenation. But you might be wondering, well, the result of this is going to be a number, right? But the rest of the things that we're adding here are strings. So how is this going to work? Well, this has to do with something called type coercion, which is something that we're going to talk about a little bit later in this section. But basically, JavaScript will simply convert this number to a string so that it can concatenate them, so that it can join them with the rest of the strings. So you will see that it's going to work just fine. Okay, years old. And then the job. And then we can finish with an exclamation mark or something like that. All right. And then let's also log this to the console so we can take a look at it. Okay. So I'm Jonas, a 46 years old teacher. And we're missing some spaces here. So that's around the years old. And you see that this is kind of a pain to manage these spaces and well, to keep track kind of how the sentence is structured. And so we will see a great solution to that in a second. So now it works, and yeah, just as expected. So as I was saying, for a complex string like this one, this can be kind of a pain. And so that's why starting with ES6, we have a much better tool for doing this kind of stuff now, which is called template literals. So with template literals, we can write a string in a more normal way and then basically insert the variables directly into the string. And then they will simply be replaced. So basically a template literal can assemble multiple pieces into one final string. So let me show you how that works. So let's call this one Jonas new. And now to write a template literal, we need to use backticks. So that's this symbol here. And on the English keyboard, you will find this one above the Tab key. So again, we really need to use these backticks to tell JavaScript that we're writing a template string. The single quotes or the double quotes won't work for what we're going to do now. So now, as I said, we simply write a string and insert the variables in there. So I'm, and then we use the $, curly braces, and then the variable name. So I'm first name. And just to see if this actually works, let's log it to console. So that's Jonas new. And indeed, I am Jonas. So you see that this is much easier because all we have is this one string, and then here we used this syntax to insert the first name variable. And now we can continue this, and it's going to be a lot easier. A, and then again a variable. Now in this case, we actually need a calculation, and that's no problem at all. We can basically write any JavaScript here inside of these curly braces. All right. Technically, we can write any expressions, but more about expressions in one of the later lectures. So year minus birth year, just as we did above. Year, old, and then teacher. So no plus signs, no thinking where we should put the spaces like we did here. And so this is a lot easier. Let's reload. Oh, and indeed, there is a bug here. So of course, that's not teacher. That's actually the value of the variable job that we're interested in here. But once again, we found this bug because we simply read the error message. So get into this habit of always reading the error message to try to figure out where you are wrong. All right. And now, of course, it works. And I hope that you can see that this is a way easier way of writing this string. This really kind of assembles the string using the pieces that we give it. For example, this variable here, or this value that is produced by the minus operator. Great. So now you know how template strings work in JavaScript, and in particular in ES6. And actually, it's one of the most used ES6 features. It's really amazing and really useful in many situations. Now, I just wanted to let you know that we can actually also use backticks to write all strings. So strings where we do not insert any of these kind of placeholders here, like this. So we just demonstrate that to you. So we can use backticks for any regular string. So you see that it works here just the same. And many developers actually started using backticks for all strings, because then you don't have to think about which quotation marks you should use. You just use backticks always. And then in case you need to insert a variable, then it's much easier than to go back and switch out the regular quotes. So that's a choice that you can make. I actually don't do that myself, but I can see that it actually makes sense. All right. Now, another great use case of template literals is to create multi-line strings. So that's something that before template strings was a bit cumbersome to write. So let me just show that to you. So if you wanted a multi-line string before ES6, you would have to write string with, and then you needed this \n, which in many programming languages means new line. All right. So basically this is like a special character in programming, which in strings always means that a new line should be created. And then in JavaScript, we would need another \, like this, and then we could move to the next line and continue here. Multiple, let's create a new one, and then lines. And this actually only works because of a bug that's in the language. But let's see. So we get string with multiple lines. And you see that it's all the same string, but yeah, spread across multiple lines. But indeed, now with template strings, there is an easier way of doing this. So all we have to do is simply hit return, and it will create a new line for us. And this is actually going to be immensely useful later when we start building HTML from JavaScript. So by then we will be able to use these backticks to create multi-line HTML elements to insert them onto a page dynamically. So that's going to be a lot of fun. Let's just see if this works. And indeed, it does. So whenever you need a multi-line string, you always make sure to use this template literal, because it's a lot cleaner. All right, and that's actually it about template literals. In the next lecture, we will finally start to make our code a lot more fun and take it to the next level by taking decisions. Welcome back. Let's now make coding even more fun and actually take decisions with our code to make it look a lot more real. So let's say that we want to write a program which checks whether a person is allowed to start taking a driver's license or not. And if she is, then it will print that to the console, and if not, it will print how many years are left until the person can start taking the driver's license. So let's start with an age, and let's set it to 19. So we have this age, and we already know how to check if this age is at least 18, which is the legal required age to start a driving license, at least here in Europe. So let's actually create a variable with that. And I think we actually already did that. Let's call this one is old enough. So again, with a variable name that describes exactly what we want here. So remember, to check if the age is at least 18, we need it to be greater or equal than 18. And so this will then include 18. So if the age is 18, the result of this operator here, or of this operation, will then be true. Only if the age is 17 or 16 or anything below, it will turn out to be false. Okay, so we have a Boolean value now, and we can use this to take decisions using an if statement. And the if statement works like this. All we have to do is write if, then open parentheses, and then in here goes a condition that is evaluated. And if this condition turns out to be true, then this block will be executed. So basically whatever code that we write into this block, which is denoted by these curly braces, will be executed whenever the condition that's here is true. So in this case, let's put the condition, and with condition I basically mean something that is a Boolean value. So let's use our is old enough variable here, because we already know that this will always be a Boolean. So again, whenever this value here is true, then the code that's in this block here will be executed. And if it's false, well, then it's not going to be executed. So let's log to the console. Sarah can start driving license. And let's just add a fun emoji here. And on the Mac, that's Command Control Space, and on Windows 10, the shortcut is Windows plus the period sign. But adding the emoji here is also not really important. So let's give it a save and try this out now. And indeed, we get Sarah can start her driving license. And that's because the age is 19, and so it's above 18. So this is true. And so if is old enough is true, then this block of code here will be executed, which in this case is just one line, but it could of course be multiple lines. So now let's put it to something else. So 15. And so now this is false. And so then this code block here should not be executed. So give it a save. Let's try. And indeed, we get no output this time. And so that means that it worked. So let's put it back to 19. And in practice, we always write this condition directly here. So let's do that. So what we want is just this part. So let's get rid of this. And so this is a lot more common. Let's actually get rid of this. And so we basically do this operation here. This will then return true or false. And depending on that, this code block will then be executed. And actually, let's put it back to 15, because now we can do something else, which is to actually add an else block. And we do that simply by writing else right after this first if block, and then we add another block. So what do you think this else block is for? Well, this else block will basically be executed whenever this condition here is false. So right now the age is below 18, and so this is false, and so as we already know, this block here will not be executed. Instead, the else block will be executed. So whatever code we have here. So let's write some code in here. And as I said in the beginning, we will calculate how many years are left for Sarah to start taking her license. So let's calculate that. Years left. And so that's simply 18 minus the age, right? And then we can log a nice string to the console which contains this variable. And as we learned in the last lecture, the best way of doing that is to use a template literal. So backticks, and then we say Sarah is too young. Wait another, and then we insert or placeholder here, basically. So years left, and then years. Okay. So the result of this should be 18 minus 15, which is 3. And so we should see wait another 3 years. So let's check that. And indeed, that's exactly what we got. And so again, since this condition here, so this operation basically turned out to be false, then this block of code was executed. Great. Just keep in mind that this else block is actually optional, right? So in the beginning, we didn't have this else block and it still did work. So when there is no else block, JavaScript will then simply move on to the next line after the if statement in case that the condition is false. Great. Now you know what an if-else statement is and how it works. And this is actually one of the most important things in programming. We take decisions with code all the time, which is essentially what we did here, so that we can execute certain parts of our program based on certain conditions. Okay? Now what we have here, this if-else statement, which is the official name of this kind of construction here, is called a control structure. So basically this structure here is called an if-else control structure. And it is called a control structure because this structure actually allows us to have more control over the way that our code is executed. For example, in this if-else statement, the whole code does not just execute in a linear way. So JavaScript does not execute all of this code here linearly. Instead, we can now control blocks of code that should execute and blocks that should not execute. And so again, that gives us a lot more control over how our code works. And that's why this is called a control structure. Okay, and there are other control structures that we're going to go into a bit later. All right, so I hope that you can see how this really takes our code to the next level. Now, just to make sure that you really understood this concept, let's create another very small and simple example here. And this time, let's actually create a variable conditionally and not just always use console.log. So let's create a birth year variable. I think we don't have it in this lecture yet. That's right. And so now what we want to do is to create a variable called century, which will basically contain the century in which this person was born. So in this case, it was the 20th century. But for example, if the person was born in let's say 2015, then it would be the 21st century. So to do that, we can of course write an if-else statement. So we can say if the birth year is below or equal to 2000, then let century equal 20. And so that then means the 20th century. And if not, then let century be 21. So we're assuming that the person is not born in like the 19th century. So we're not accounting for something like this, for example. So instead, we always have the 20th or the 21st century. Now, to actually make this work, we need to define the century variable outside of the if or else blocks. We will go deeply into why that is, but for now, what you need to know is that this is because a variable that we define inside of any code block, which is what this here is. So this is a code block, and this is a code block, and any variable that we declare inside of one of these blocks will not be accessible outside of the block. So let me just show that to you very quickly. So if I try to read century now, then I will get an error here. You see, century is not defined. And so what we need to do is to define century outside and simply leave it empty. And then in here, we can then conditionally reassign it. Okay? And so now let's see how this works. And indeed, now we get the century 20. So 1998 is below 2000, and so this person was born in the 20th century. Now let's say 2012, and so that should now be 21st century. And indeed, that's exactly the result. So I hope that this example 2 made sense to you. Now, don't worry about the fact that we had to declare the century variable outside of the blocks. What matters here is that you understand the logic of the if-else statement. Okay? And I hope that was clear enough. But anyway, let's quickly recap. We can take decisions using code using the if-else statement. And for that, we write if, and then we open up parentheses, and in there we need a condition. And a condition is essentially any code that returns a true or a false value. And so this is a perfect example of that, because this operator here will return true or false, right? And so we can use this operator to create a condition, essentially. Then, if the condition is true, this block will be executed. So all the code that is in there, no matter how many lines of code there are. Now, if the condition turns out to be false, then this else block will be executed instead. So JavaScript will then skip this first block and go to the second block, which is this one. But the else block is actually optional. So if you don't have the else block, then simply no code will be executed. And this, in a nutshell, is how the if-else statement works. And remember that this is really powerful. So make sure that you really understand how this works. And when you do understand, then you can move on to the next video where there is a small challenge waiting for you. Welcome to the second coding challenge. And in this one, you're going to test your knowledge of the if-else statement that we just learned about. So this coding challenge number 2 will basically improve the first challenge. So we're still going to be using the BMI example, but we are going to print a nice output to the console, and this output is going to tell us who has the higher BMI. So the output message can be either Mark's BMI is higher than John's, or John's BMI is higher than Mark's. So that's the first part, and then as a second part, use a template string to include the actual BMI values in the outputs. Okay, and as you can guess, you should probably use an if-else statement to complete this challenge, right? So pause the video now, and I see you in a second. All right. Again, I hope that you managed to do this. So let me show you how I did it. So let's start by getting this code from the other challenge. So coding challenge number 1, because of course we don't have to repeat the same code. So here we have the mass and the height of both John and Mark, and we already have their BMIs calculated. We also have this condition here basically already. So this operation here already tells us whether Mark has a higher BMI or not, right? So let's get rid of this. And so let's write our if-else statement. So if BMI Mark is greater than BMI John, and here we could have just used this variable, right? So we could have written Mark higher BMI right here. But as I said in the previous lecture, it's actually more common to write the condition directly in here. So let's get rid of this variable here. And then let's come here and get this string that we want to then log to the console. So console.log. And so this makes sense, right? So if BMI Mark is greater than BMI John, then we log to the console, Mark's BMI is higher than John's. And if not, then we use the else statement. So let's copy this one here. So in this case, John's BMI is higher than Mark's. And actually, let's log both of them to the console here first, just so we see if our if-else statement is working as expected. So BMI Mark and BMI John. And as you see here, the VS Code auto-completion is pretty smart. Give it a save. Let's try that. And we see John's BMI is higher than Mark's. So this one is Mark's, this one is John's, and indeed, John's BMI is higher. And so basically, this condition here turned out to be false, and the else block was executed. So let's try the same now with this first set of data here. And I'm commenting them out again using command/ or control/ on Windows. So I need to comment out this one. Okay, give it a save. And now we should see the opposite. And indeed, now Mark's BMI is higher than John's. So that is part 1, right? And now part 2 is to actually write a template string, or this would be called a template literal. We just fixed that. So we should use a template literal to include the actual BMI values. So like this here between parentheses. So let's do that. And so we're going to transform this to backticks. So that's the first thing. And then let's see the template again. Okay, so after the BMI, we include the parentheses. And then in the parentheses is where we want the actual value. And so this is where we put essentially the placeholder. So here we will put BMI Mark. And here BMI John. Right, and now let's just copy this to make it a bit faster. Mark, and then here John. Okay, let's see. And yeah, that works just fine. Cool. So with this, we solved the challenge. And again, if you did it in a slightly different way, don't worry at all. That's completely normal, and it's actually a good thing. It means that you're basically finding your own style of coding, which is really a good thing. So don't worry about that. What matters is that you actually used an if-else statement. That was, of course, mandatory. Otherwise, you couldn't have made this work at all. All right, so this was a lot of fun because we actually made our code do something now. I hope you can really feel that as well. In this video, we need to go back to value types. So types are one of the fundamental aspects in programming, and converting between types is something that we do in every programming language. For example, converting a string to a number or a number into a Boolean is something that we do all the time. And so it's important that we learn about this before being able to move on further in the course. That's especially true for a language like JavaScript, which sometimes behaves in a weird way, as we will see in this video. Now, in JavaScript, there is type conversion and type coercion. So they sound very similar, but are different. So type conversion is when we manually convert from one type to another. On the other hand, type coercion is when JavaScript automatically converts types behind the scenes for us. So that's necessary in some situation, but it happens implicitly, completely hidden from us. Okay? So let's start with type conversion, which, remember, is when we explicitly want to convert from one type to another. So let's say that we have an input field on a web page for the user to input their birth year. And these inputs from input fields usually come as strings. So let's say that the input year that we get from the user interface is a string with the value 1991. But now, if we want to do some calculations with this, this won't really work. So let me show that to you. So console.log, let's say input year, and now plus 18. And so like this, we can calculate in what year the person will become of full age. Now, remember that when we have a string and add something to the string, it will basically concatenate the strings. So we can't expect that this actually adds 18 to this number here, because it's a string. So let me show you what I mean with that. And so indeed, we now get a string, which basically contains the 1991 string and then the 18 as well. Okay? So we need a way of fixing this, which means that we need a way of converting this string to a number. So let me actually log that here first. So console.log. And then the way we convert this string to a number is by using the built-in number function. So we write number, then parentheses, and then input year. And we will learn exactly what a function is and why it works this way in the next section. For now, just know that we can basically convert strings to numbers by using this function, which we execute using these parentheses here. So we have these parentheses inside these parentheses now, but don't get confused by that. So doing this operation here will then return the string as a number. So let me show that to you. And so indeed, now we get 1991 here in this pink color, basically. And the colors might change throughout the time. By the time I record this video, numbers are pink and strings are just this white. Let me actually print them both. And so that should make it really visible that, yeah, the first one is a number, the second one is a string. Okay. But now one thing that's really important to note here is that the original value is actually not converted. So the input year variable itself, so this one is still a string, right? It still holds the variable 1991 as a string and not as a number. That's why down here in this log, where we do this calculation, the result is still this string. Because again, the original input year variable is still a string. Using this number function will simply give to us a converted version. So if we want to perform this calculation, we need to use number here as well. And so this will now convert the number, and then to that number, the 18 will be added. And so now we should end up with something like 2009, I guess. And indeed, that's right. But now, what if we're trying to convert something to a number that is impossible to convert? Let's try that with a string that doesn't really contain a number. So let's try to console log converting to a number the string Jonas. So JavaScript will look at the string, will try to convert it to a number, but it won't really work. So what do we get instead? We get this nan, which stands for not a number. So JavaScript gives us this not a number value whenever an operation that involves numbers fails to produce a new number. So basically, not a number actually means invalid number. It's not really not a number. And let me actually prove that to you. So we can check the type of NaN, so not a number. And as we will see, the weird result of this is that the type of not a number is actually number. And so again, not a number actually means an invalid number. It's still a number somehow, but it's an invalid one. And so again, we get not a number whenever an operation involving numbers fails to give us a new number. Okay, so that is converting strings to numbers, but of course we can also do the opposite. It's a little bit less important, I would say, but I still want to show it to you. So to do it the other way around, we use this string function, and that's quite straightforward, right? Just keep in mind that we need to really start it with a capital S, just like here the number function needs to start with a capital N. Otherwise, it's not going to work. So we get 23. And remember that whenever the value here is white, then it means it is a string. So it looks kind of the same. Let's again log both just to make this point. So the pink one is the value that actually has the number type, and this one has the string type. Okay, so again, this one is not as important, but I still wanted to mention it. Now, JavaScript can only convert to 3 types. So we can convert to a number, to a string, or to a Boolean. But we cannot, for example, convert something to undefined or to null. That doesn't make a lot of sense. Now here we only converted to numbers and to strings, but not to Booleans. And that's because Booleans behave in a special way. And for that reason, there is a separate lecture coming up on so-called truthy and falsy values. Great, so that is type conversion, where we do manually convert from one type to another. However, in practice, we rarely have to do it manually, because JavaScript actually does type coercion automatically for us in many situations. So let's talk about that now. And let's just separate it here with some comments. So type conversion, and then type coercion. So basically, type coercion happens whenever an operator is dealing with 2 values that have different types. So in that case, JavaScript will then, behind the scenes, convert one of the values to match the other value, so that in the end, the operation can be executed. And actually, we already saw that happening, if you think about this. So let me show that to you. Starting with strings, remember how we did this. I am, and then a number, let's say 23, and then another plus years old. So we already know that this is going to produce a string that says I am 23 years old. But how does that actually work? Because 23 is a number, so we have different types here, right? We have a string, a number, and another string. So let's check, and indeed that is what happens. And it works this way because of type coercion. So in JavaScript, the plus operator that we used here triggers a coercion to strings. And so whenever there is an operation between a string and a number, the number will be converted to a string. So thanks to type coercion, writing this would be exactly the same as writing this. right? Because again, the plus operator will convert numbers to strings. And the same actually happens in template literals. It also takes all the number values and also converts them to strings. Now, if JavaScript did not have automatic type coercion, like many other languages don't, then we would have to manually do this like we just learned before. Then we would have to do string 23, and then this would be the only way that this would work. But luckily for us, JavaScript has type coercion, and so this will happen completely automatically behind the scenes. Now, actually, not all the operators do type coercion to string. So let me show you something else. So if we do 23 the string minus 10 the string minus 3, what do you think will happen now? So let's actually check. And it gives us 10. So what happened here? It looks like this time JavaScript converted the strings to numbers. And indeed, that's why we get 10. Because 23 minus 10 is 13, minus 3 is 10. And so what this means is that the minus operator actually triggers the opposite conversion. So in this case, strings are converted to numbers and not the other way around. So instead, if we use the plus, what do you think is going to happen? Then the 3 is converted to a string, and then the 3 strings are concatenated. Okay, so this is a very important distinction to keep in mind, because this actually confuses many JavaScript beginners when they don't know about this. So let's try another one here, and I'm again using 23 the string times 2 the string. And again, you will see that these values are going to be converted to numbers before. And indeed, that's why we get 46, because both of them are now converted to numbers, because that's the only way that the multiplier operator can work. And the same, of course, is true for dividing. Okay, so I hope that the distinction between type conversion and type coercion is now pretty clear. And now just to make sure that you actually got it, let's play a game called Guess the Output. So that's a game I just made up. So I want you to guess what happens here. So I'll write 1 plus 1 like this. And then we say n equals n minus 1 again. So what do you think n will look like when we log it to the console? So essentially we start with 1 the string, then we add 1, and then we subtract 1. So take a moment to think what this should look like, and then let's take a look at the solution. And it is 10. So that's a bit counterintuitive, but according to the rules that we just learned before, it actually makes sense. So here in the first line, 1 plus 1 will actually turn out to be 11 the string, because we have one string here, and then the plus operator will automatically convert the number to a string. And so the result of this one is the string 11. But then here we have the minus operator. And in the minus operator, whenever we have a string or more strings, it will then convert it to a number. And so here, the string 11 will be converted to 11 the number, and then 11 minus 1 is of course 10. Okay, let's do one or two more, and let's do it in the console here. And we can actually clear the console of all this clutter here by clicking on Clear Console. Okay, so let's do 2 plus 3 plus 4 plus 5 the string. And now you actually can't really guess because we can already see the solution there. Okay, so let's try to understand what happened here. So we start here with 2 plus 3, which makes 5. Then 5 plus 4 makes 9. And then we end up with 9 plus 5 the string. And then, as you already know, since we have a string, the plus operator will convert the other operand, which is 9, also to a string. And then we end up with 9, 5 as a string. Okay, and another one. 10 minus 4 minus 3. And keep in mind that these are strings. And then minus the real number 2. But then plus 5 the string. So again, this looks very weird, but the logic is kind of the same as before. So we have two values that are subtracted, and so JavaScript will convert them both to numbers. And so the result of this is 6. Then 6 minus 3 is 3. Then 3 minus 2 is 1. And then we end up with the same situation as before. So this 1 will be converted to a string, and then we end up with the string 15. Okay, and with that, I think this should be pretty clear now. And you might be wondering why we're talking so much about this, but it's really important that you know about this right from the start so that you can write your code with all of this in mind. Now, many people actually don't like type coercion and think that it's a bad practice to rely on type coercion. One reason for that is that type coercion can, in fact, introduce many unexpected bugs into our program. However, this only happens when we don't really know what we're doing. So when we don't know about the stuff that I just showed you. Because if you know, then it's way easier to avoid these errors. So in my opinion, coercion is actually a great mechanism that is going to allow us to write a lot less code and also to write more readable code. So really make sure to take some time to understand how type coercion works and then just embrace it in your code. So we talked about type conversion and coercion to numbers and to strings. But I didn't mention booleans yet, right? That's because we need to learn the concept of truthy and falsy values first. And so that's what we're going to do now. So let's get right into it. So falsy values are values that are not exactly false, but will become false when we try to convert them into a boolean. And in JavaScript, there are only 5 falsy values. And let me actually write them down here for you. So 5 falsy values. And they are 0, the empty string, undefined, null, and not a number. And that's it. Of course, false itself is already false. So we don't need to include it in the list of falsy values. So again, all of these 5 values will be converted to false when we attempt to convert them to a boolean. They're not exactly false initially, but they will become when converted to a boolean. So that's the definition of falsy values. Everything else are so-called truthy values. So values that will be converted to true. For example, any number that is not 0 or any string that is not an empty string will be converted to true when we attempt to convert them to a boolean. And so let's actually see that in practice. So just like with numbers and strings, we can use the boolean function, boolean, and then 0. And we know that this one is a falsy value, right? So let's copy this and do this a couple times for some different things. Let's do the same with undefined. Let's do it now with a string. And it's not an empty string. And now let's also do this with this empty object. And we will learn about objects in the next section. So this here is simply an empty object. So let's see what the result of this is going to be. And we see that indeed converting the 0 here to a boolean resulted in false. And the same for undefined. It's also false. But then the string Jonas is true. And so that's why we say that any string that is not an empty string is a truthy value. And the same actually applies to this empty object here. It's also a truthy value. But if we tried to convert an empty string, well, I think then you can already know what the result will be. And it's going to be false. Again, because it's a falsy value, as we see up here in this list. So that's what truthy and falsy values are. And this is how we could convert them to booleans. But in practice, I actually never did this in my life. I never used this function here in practice. This was just to show you the concept of truthy and falsy values. So in practice, the conversion to boolean is always implicit, not explicit. Or in other words, is always type coercion that JavaScript does automatically behind the scenes. But when exactly does JavaScript do type coercion to booleans? Well, it happens in two scenarios. First, when using logical operators, and second, in a logical context, like for example in the condition of an if-else statement. And we're going to talk about logical operators in a future lecture, so let's now go back to the if-else statement and see how type coercion works in the if-else condition. So let's say that we have a money variable. And in the beginning, we don't have any money. So we set it to 0 here. And now we can use what we just learned to test if the person has currently any money or not, right? So let me actually write it first, and then I'm going to explain to you how it works. So if money, then let's log to the console something like don't spend it all. And notice how I used the double quotes because in here I have a single quote for the don't. And then we can also do an else block. So for the case that the person does not have any money, then I can just say you should get a job. Okay, so let's see if this works, and then I'm going to explain to you why it works. So indeed, we got the you should get a job, and so that's the else part here, right? So this here is the code that got executed. But why? Well, we know that money is a number right now, and this number is 0. But in the logical context of an if-else statement condition, so that's right here in these parentheses, here JavaScript will try to coerce any value into a boolean. So no matter what we put here, if it's not a boolean, JavaScript will try to convert it to a boolean. And that happens using the truthy and falsy value rules that we just discussed in the beginning. So we know that money here is 0, but 0 is a falsy value, right? And so in this logical environment here, in this condition, this number 0 will be converted to false, just like it happened here when we converted manually the 0 to a boolean, right? So here this conversion to boolean returned false. And here the exact same thing happens. Money is 0, and so 0 is converted to false because it's a falsy value. And as a result, the else block here is executed, and so on the console we see you should get a job. Now if we change this to something else, and it doesn't matter what number, let's say 100, then 100 is a truthy value. And so this means that this condition will be true. And so the if block will be executed. Want to see? Yes, indeed. Now it says don't spend it all. Great, I hope that made sense. And we can test this in another situation to make really sure that you understand it. So another use case for these truthy and falsy values is to check if a variable is actually defined or not. And this might seem like a weird use case, but you will see later in the course that it actually makes a lot of sense sometimes to test if something actually exists or not. So let's define a variable here as height, and then we can simply do this. If height, then let's run this code. Yay, height is defined. But if not, well, then just say height is undefined. Okay, so let's see the result, and again I will explain you why it works this way. And maybe you can already guess why it works this way. So can you try to explain it to yourself maybe? That would be a good idea to make sure you actually got the concept. But anyway, we know that height is undefined in this moment, right? Because we didn't assign it any value yet. And we know from our little list here that undefined is a falsy value. And therefore, just like before in the money here, this height variable here in this logical context will automatically be converted to a Boolean. And since height is undefined and undefined is a falsy value, height right here will be false. Therefore, this block here will be executed. But now if we assign something to it, no matter what it is, then we will get the other result. So now it's true, and so now this block here is executed. However, with this, we can actually run into a problem. So let's say that the height is 0 for some reason, and that's a perfectly valid number. But watch what happens when we run this code. Now we get again, height is undefined. So, why is that? And I hope you know the answer by now. Well, it's because 0 is also a falsy value. And so this one will also trigger this else block. But in this case, that's actually not what we want. So this is kind of a bug. It's an error in our application. Because here in this if-else statement, we didn't account for this scenario. We only accounted for the scenario that the height is either defined or not. But we didn't think of the height being 0, right? And so right now we get height is undefined, even though that's not true. So this is just to illustrate an example that there can be problems using this approach. However, we can fix this using logical operators, which is going to be very interesting, and we will talk about that a little bit later in this section. But first, in the next lecture, we need to talk about equality operators. So stay tuned for that. So far, we have only used comparison operators to take decisions with if-else statements, right? But let's suppose we want to check if two values are actually equal, instead of one being greater or less than the other. And for that, we have different equality operators. So let's start again with an age variable and set it equal to 18. And I'm using age all the time because it's so easy to make simple calculations with it. So let's now create an if statement which will log to the console that the person just became an adult only if the age is exactly 18. So we can use an if statement, as we already know. And now to check if the age is exactly 18, we use the triple equal. Okay, and that's it. Let's now write the block of this if statement and then execute it, and then I will explain what happened here a little bit better. Now, whenever our if block only has one line, we actually don't need the curly braces. Okay, so we don't need to create this block if we only have one line. So we can omit this and only write this one line of code. In this case, you just became an adult. So let's test this. And indeed, the result is that we see this string logged to the console. And if the value would be something else, for example 19, then age is no longer equal to 18, and so we shouldn't see this result. And indeed. But let's put it back to 18. Okay, so how does this equality operator here actually work? Well, just like the comparison operators, this operator will return a true or a false value, so a Boolean value. Only that in this case, true will only be the result of this operator in case that both sides are exactly the same. All right, let's actually show that result to you. And actually we can do that right here in the console. So if I say 18 equal to 18, this will be true. But if I say 18 equal to 19, it will be false. And so that's exactly what we used here as a condition in this if block. So don't confuse the assignment, which is just the single equal, with the comparison operator, which is this triple equal. Now, besides this triple equal, we also have a double equal. So the difference is that this one here with the 3 equals is called the strict equality operator. It's strict because it does not perform type coercion, and so it only returns true when both values are exactly the same. On the other hand, there's also the lose equality operator, which is only 2 equals, and the lose equality operator actually does type coercion. So let's see that here in the console again. So in this case, I can do 18, the string, equal 18, the number, and it will still give me true. So again, the double equal does type coercion. So what this means is that this string here, this 18, will be converted to a number. And then the number 18 is the same as this number 18. Now, as I mentioned, the triple equal does not perform type coercion. And so let me show that to you. And so it's false, because 18 the string is of course different than 18 the number. So it's not the same, and JavaScript does not convert them for us. So let's try that also here in our code. And I'm just gonna copy this one. And then this. And let's say here lose, and here strict. So if I run this now, both these conditions should be true. So 18 the number, which is the age right now, is equal to this 18 the number, right? It's strictly equal, but it's also loosely equal. So 18 the number is of course also loosely equal to this 18. So let's run that. And indeed, we get the strict and the loose string printed to the console. But now if we change this to 18 the string, well, what do you expect to happen then? And indeed, only this line of code here is executed. So this one which says lose here, as we see here. And so that's because of the result that I showed you earlier, which is that with the lose equality operator, 18 the string is the same as 18 the number, because 18 the string will be converted to 18 the number. So I hope that's not too confusing for you. It is actually quite a confusing topic in JavaScript, because this lose equality operator, so this one here, is full of really weird rules and behaviors. This means that if we use this one here, this can introduce many hard to find bugs into our code. So as a general rule for clean code, avoid the lose equality operator as much as you can. So when comparing values, always use strict equality with the 3 equal signs as I showed you here. And that's the reason why I showed you this one first. This is something that actually most JavaScript developers advise you to do. So it's a good rule for sure, even if we actually need type conversion. In that case, it's better to convert the value manually before the comparison than relying on the double equal operator. So always default to the triple equal operator and pretend that this one doesn't even exist. Okay, of course I still needed to show it to you, but from now on we will assume that it doesn't even exist. Great, so let's do another example here, because I actually have some more great stuff to show you. And the first thing that I want to show you is that there is a pretty simple way of getting a value from any web page. We can do that by using the prompt function. And again, we will learn what functions are in the next section, but this is how it works. So we just write prompt and then a string. And let's ask the user for his favorite number. So what's your favorite number? So let's see what happens when we load this now. So we get this prompt window. And here we can input something and then hit return. So basically all this here will create a value, in this case the number that I just inputted. But we need to store this value somewhere. So let's create a variable called favorite. And so it's in this favorite variable where the value that we put into that form will be stored. So let's take a look at that. Console.log favorite. So 23. And you see that it now logged the value. But it's printed here in white. So remember, that means that it is a string. Let me prove that to you by checking the type. So by now we know how to always check the type, right? It's pretty simple. And so now we should see string. Now, of course, we have to give the number again. So 23 is the result, and it is indeed a string. So now let's write some logic here to check if this is a great number, basically. So let's say if the favorite number is equal, and let's use this one first. So if the number is equal to 23, then let's log to the console. Cool. 23 is an amazing number. Okay? And so now this should actually work, shouldn't it? So 23, and we get this result. So again, why is that? Well, because we used the double equals here, which is the loose equality operator. And this one will do type coercion, right? So right now what we have here is basically 23, the string, which is this one here, equal 23. And so this one will be converted to a number, and then the number 23 is of course equal to 23. However, if we use the triple equals, so the strict operator, then it should not work. So 23 again, but we do not get that log. And by now you already understand why that is, right? So remember how I said that we should always use this one. And so we now have to convert this string to a number. And we can actually wrap all of this into that number function that we used to convert. So number, and then we put all of this here, which is the one that will generate the string 23, and then we wrap that into the parentheses to execute the number converter. And so right now, favorite is going to be a number, and so then this should be back to working, because then at this point we have 23 equal 23. And so that, of course, is true here, and so then this line of code will run. So 23, and indeed it does. And you see that it's also now pink, meaning that it's a number. And if I use something else, then of course this here is also false. So if I have 22 here, then this will of course be false because they are different. But this actually brings me to my next point, which is the next cool thing that I wanted to show you. And that is that we can actually add more condition to an if-else statement. So far we have only used if-else. However, we can also add an else-if block. And that works like this. So else, and then a new if. So let's now do favorite equal to 7. And then let's say 7 is also a cool number. And so what this will do is to first check if the number is 23 here. Then if it's not, it will of course go to the next block, which is this one, and then it will check this condition. Well, if the number is 7 now, then run this code. And then at the end, we can also add an else block. So let's say number is not 23 or 7. So let's test that. So if I put 7 now, we get 7 is also a cool number. And so that's our else if block here. So this second one here running. But now if I do something else that is neither 23 nor 7, then we go to that last else block here. Okay, and we can actually keep adding more and more. So we can do this as long as we want. So we can do else if favorite triple equal 9, for example. Let's simply grab this one here. Say 9 is also a cool number. And then number is not 23 or 7 or 9, just to make it really complete. And so now if we use the 9, then 9 is also a cool number. So we now have a way of not going immediately into the else block once the initial condition is false. So if this one is false, it doesn't immediately go into the else block. There are now other conditions that can be checked one after the other. First, we check for 23, but if it's not 23, we check if it's 7. If it's not 7, we check if it's 9, and if it's not 9, well, then the final else block will be executed. Okay? I hope that makes sense. And we actually use this from time to time. Okay, and now to finish, there's also an operator for different. So we talked about equal, but of course, there must also be an operator which does the opposite. And so that's the different operator. And so let's now check if the favorite is different from 23. So we use the exclamation mark and then the double equal, which is the strict version, and then there's also the loose version, which is this one. So with just one equal. But just as before, always use the strict version. So if the number is not 23, we can log something like saying, why not the 23? Okay, let's try that. And let's use 9. So what do you think will happen when we use the number 9? So we get first this log here from this else if block, right? But then we also get this why not 23 message. And that's of course coming from this if block here. So 9 is of course different from 23. And so this code here is being executed. But now if we actually use the 23, then only this line of code is executed and this one here isn't, because the favorite number is now equal to 23. And so of course it doesn't make sense to then execute this one here. So sometimes we need the different operator and sometimes we need the equality operator. Just choose whatever you need to solve any particular problem. In both cases, just make sure to use the strict version of the operator. When we learn about if-else statements, comparison and equality operators, and Boolean values, we also need to learn about logic, and in particular about Boolean logic. So let's do that in this video. So basically, Boolean logic is a branch of computer science which uses true and false values to solve complex logical problems. And in order to do that, it uses several logical operators to combine true and false values. So much like we use arithmetic operators to combine numeric values. Now we're only going to scratch the surface here and talk about the most basic logical operators, which are the AND, OR, and NOT operators. And note that Boolean logic is actually not specific to JavaScript. This is all true for all programming. But anyway, let's now understand how these operators work and use an example to illustrate it. So here we have two Boolean variables that can either be true or false. So A is that Sarah has a driver's license, and B is that Sarah has good vision. So both of these are of course conditions that can be true or false, because Sarah could have no driver's license and she could have no good vision, right? And of course, on the other hand, she could also have a driver's license and could have good vision. Now, using the AND operator like A and B, we can combine these two Boolean variables like Sarah has a driver's license and good vision. Okay, but now what will be the result of this operation? Well, for that we use a so-called truth table, which looks something like this. Here we have the two possible values for each of the variables A and B, which gives us 4 possible combinations of results. And so then all we have to do is to plug in the value of our variables and get the result of the AND operation from this table. So what we can see from this table is that only if both A and B are true, the result of the operation will be true as well. And that makes sense, right? After all, it's called the AND operator. And so again, what the AND operator does is to return true only if both A and B are true. In all other situations, if either A or B are false, then A and B will also be false. And we can also generalize this to more operands, so to more than just two values. We could do A and B and C, and the result would be true only if all of them are true. And if one of them is false, then the result is immediately false as well. Now, I know that all of this might look a little bit confusing, but don't worry, we will have an example a little bit later in this lecture, and we will also use this in practice in the next one. And after some practice, you will internalize all of this, and you won't even need any truth tables. Now, moving on the other hand, we also have the OR operator, which kind of works in the opposite way. So with our current example, we could use the OR operator to determine whether Sarah has a driver's license or good vision. And just by thinking about this, we can already intuitively imagine that the OR operator will be true if just one of the variables is true. And in fact, a look at the truth table confirms exactly that. So unlike the AND operator and the OR operator, even if one of the variables is false, the outcome will still be true. Or in other words, if either A or B is true, then the OR operation becomes true as well. And that's why it's called the OR operator. And once more, if we have multiple variables, it's enough for one of them to be true to make the whole operation become true as well. Okay, I hope this makes sense. And once again, I can assure you that it will make sense once we start using this in practice. Anyway, we finally also have the NOT operator, which is a lot simpler because it doesn't combine multiple values. Instead, the NOT operator acts on only one Boolean value, and it basically just inverts it. So if A is true, it will become false, and if it's false, then not A will become true. Simple as that. And that's basically how these three most important logical operators work. But of course, the best way to understand it is to use a more practical example. So let's go again back to using the age, and this time we set it to 16. And then we have our two Boolean variables. The first one is age is greater or equal 20. And the second one is age is less than 30. So let's determine the value of each of them. So if age is 16, then age is greater or equal to 20 must be false, right? And of course it is. And age is less than 30 is true, because 16 obviously is less than 30, okay? So that's the baseline basically, and now we will start to combine these variables a and b using some logical operators. So the first exercise is the NOT operator, so not a. And we know right now that a is false, right? So the result of not a, as we just learned, is true, because all it does is to invert the logical value of the variable. Next one, we have a and b. And we already know that a is false and b is true. So I'm just putting these values here again to make it a bit easier to follow, okay? So we have basically false and true. So from a look at our truth table here at the right side, we can easily determine that the result of this must be false. And so that's exactly what we learned before. So when we have the AND operator, it's enough for one of the operands to be false to make the result of the operation also false. Now we have A or B, and so let's check out the truth table in this case. And so in this case, we actually get true. And so this shows that it is enough for one variable to be true for the whole expression to be true as well. Next up, let's check not A and B. And we already know that not A is true and B is true. And so this time, for the first time, we are combining multiple operators here. And yeah, we already know that true and true will of course be true as well. And now another one combining two operators. So A, or, and B. And just as a side note, the not operator actually has precedence over the or and and operators. So basically, the values are inverted first, and only then they are combined using and or. So we know that A is false and B is true. So not B must be false, right? Then false or false is also false. And actually, that's the only way in which the or operator can be false, if all of them are false, basically. So I hope that made sense to you. And so in the next lecture, we will actually use these operators in code. And then it will make even more sense to you. So by then, we probably won't even need the truth tables anymore, because it will become quite intuitive how both of these operators actually work. But anyway, let's now move on, and I see you in the next video. Let's now return to our code and learn how logical operators work in JavaScript. And let's actually use the Boolean variables from the last lecture. So the one about having a driver's license and having good vision. So we are going to create a variable for each of them. And the first one will be has driver's license. And let's start by setting it to true. And remember that this one was variable a. And then let's create has good vision. And also let's initialize it with true. So these were the two a and b variables that we used in the last lecture as an example. And so it's a good idea to use these here as well. Okay, but now let's get started with the and or operators. So let's log to the console of using the and operator on these two variables. So has driver's license, and now the and operator in JavaScript is this one. So with this we can combine two logical values. So has driver's license and has good vision. So let's see what the result will be. So this one is true, right? And this one is true as well. So the result of true and true should be true, right? So let's see. And yes, so that works. But now, of course, we will change one of them to false. So remember, the result of true and false will be false, because it's enough for one variable to be false for the result of the operation to be false. And so here we can now confirm that, and indeed, that is the result. But now let's see what it would look like with the or operator. So I just copied this and pasted here. And now instead of and, we use or, and that looks like this. So again, true or false. What do you think it will be? Remember from the last lecture. And the result is true. So it's enough for one of the variables to be true for the whole operation to become true. So I hope that's nothing new at this point. And of course, finally, we can also use the not operator to basically invert one of the values. And the not operator in JavaScript is the exclamation mark. So not has driver's license will become, so it will change from true to false. All right. And now, since we know how all of this works, we can use these variables to take a decision. So let's say that we want to determine whether Sarah should drive or not. So let's create a new Boolean variable and use the others to determine that. So let's say should drive. And our model is that Sarah should drive if she has a driver's license and at the same time has good vision. Okay? And so, as I mentioned in the last lecture, we can now use these Boolean variables and this Boolean logic to model complex situations. And this one is actually pretty simple, but we will take it up a notch by the end of this lecture. So remember, a model is that she has a driver's license and that she has good vision. Okay, and now we can use this variable to finally take the decision. So let's then use this Boolean variable here and say, if she should drive, then log to the console, Sarah is able to drive. And if not, just log someone else should drive. Okay, and actually, we can put the condition right here in the if condition. So this was just to show you a little bit the thought process. But as I mentioned earlier, we usually create the condition right here in the if statement. So give it a save, and now let's run it. And the result is someone else should drive. So that is because has good vision is false. And so our condition of has driver's license and has good vision is not true, because it's only true in case that both of them are true, as you already know by now. So this one is false right now, and so therefore the else block will be executed. But of course we can change it once more. And so right now both of them are true. So has driver's license, true, and has good vision, true. So true and true is true, and so Sarah is able to drive. Let's check that, and indeed. Great. And with this one working now perfectly, let's take it to the next level and add another Boolean variable here. So let's now also add is tired. And let's set it to true as well. So we can say that this is our variable C. So to use more than two variables with, for example, the AND operator, let's just go ahead and copy this one. So if you want to say has driver's license or has good vision or is tired, all we have to do is to add another or operator here, just like we would add another plus or another minus operator. And the result of this should, of course, be true because, well, all of them are true. And indeed, it is. And if we set them all to AND, then it is also true because all of them are true. But if we set this one to false, then, as you can guess, the result will be false. And that is because, as I explained in the last lecture, it's enough for one of the operands to be false to make the whole AND operation false as well. Okay, but let it set back to true. And now we can use this to improve our decision making whether Sarah should drive or not. So with this third variable now, we want Sarah to be able to drive if she has a driver's license, if she has good vision, and if she is not tired, right? So let's now translate that into a condition. And I will just copy this one and then comment all of it out using command or control slash, just like many times before. And now we will improve this one. So this one, of course, is the same, that she needs to have a driver's license and good vision. But now additionally, we want her to be not tired. So right now she is tired, it's true, and that's of course not good for driving. So we want the opposite of being tired. And so therefore we need to invert it. So do you remember how that works? All we need to do is to use the not operator. So not is tired. All right, so let's read this again. Sarah is able to drive if she has a driver's license, so if this one is true, if she has good vision, so if this one is true, and if she is not tired, so if all of this is true here. So only in this condition, Sarah is able to drive. Now, how is this part here true? Well, it's true when is tired is false, right? So what do you think will happen in this situation right now? Well, let's test and then analyze. So we get the result, someone else should drive. So why is that? Well, this one is true. This one is true, as we see up here. And then is tired is also true. However, not is tired is false. So this part here is false. And so true and false is, of course, false. And so therefore we get the else block, someone else should drive. Now to fix this, we need to change is tired to false. All right. And so right now is tired is false, and therefore not is tired will become true. And then we have true and true and true. And then in this situation, Sarah will be able to drive. Yes, indeed, it works now. So as you see, with these three Boolean operators, we can model all kinds of complex decisions like this one. Now, I know that this was probably a bit confusing, but please don't worry too much because it's all very confusing for everyone when they first learn how to program, okay? Just take some time after this video and analyze again exactly what happens here, maybe also together with the last video, to really make sure that you understand what is going on here. But of course, the best way to retain any knowledge is by practicing and reinforcing it. And so let's do that now in the next coding challenge. I hope you're excited for your next coding challenge. So let's jump right in. And this time we have a different coding challenge. So this time we have two gymnastics teams called the Dolphins and the Koalas. And they compete against each other 3 times. Then the team with the highest average score is the winner and wins a trophy. So here are your tasks. First, you should calculate the average score for each of the teams using the test data below. So this test data right here. Okay. Then compare the team's average scores to determine the winner of the competition and also print it to the console. Now there might be a draw between the teams, which means that they have the same average score. So you need to test for that situation as well. So this is the basic challenge, and I think this will be great to test the knowledge that you gained over the last couple of videos. Now, if you want to take it to the next level and make it a bit more difficult, you can try out the bonus 1 and bonus 2. So let's take a look at these. So bonus 1 is to include a requirement for a minimum score of 100. So what this means is that a team only wins if it has a higher score than the other team and at the same time a score of at least 100 points. And to help you solving this one, I'm giving you the hint of using a logical operator to test for the minimum score of 100 points. Also, you will probably need multiple else-if blocks. All right. Now, the second bonus here is that the minimum score also applies to a draw. So a draw only happens when both teams have the same score and both have a score greater or equal 100 points. And otherwise, no team at all wins the trophy. All right. And then here you have actually the test data for bonus 1 and for bonus 2. And you can, of course, play around with these scores and change them to match all the different scenarios. Okay, so these are not static. They're just some initial values that make sense. But from there, feel free to change them. So the first two are the easier ones. And for these, you use this test data. Then, to make it a bit more difficult, you can do bonus 2 and bonus 1, and for that you use these two test data sets. All right. Now, if one of the bonuses turns out to be too hard for you, then just don't do it. It's perfectly fine, okay? What matters is that you don't become frustrated. The goal here is really just to test the stuff that we did before, and absolutely not to get you frustrated and thinking that coding might not be for you, okay? And again, don't focus on writing efficient or optimized code at this point. All we want here is to learn programming and to learn JavaScript. So just make it work and yeah, That's it for instructions about this challenge. So pause the video now and I see you in a second. Okay, hopefully you managed to complete at least point 1 and point 2. And so let's start by solving these two. So number 1 is calculating the average of both teams. So let's create one variable for each. So score Dolphins. And so to calculate the average, we simply add up all the 3 scores and then divide it by 3. So we already did something similar before. So that's 96 plus 108 plus 89, and then divided by 3. And we need these parentheses so that these plus operations are executed first, because the grouping, so the parentheses, have a higher precedence. Okay, score koalas is 88 plus 91 plus 110. And again, divided by 3. And now let's quickly log both to the console here. Score Dolphins and score koalas. Okay, so they're pretty close, but the Dolphins have a little bit higher of an average. And so that's what we're working on in point 2, where we're going to compare the average of both teams. So we are going to use an if statement, or if else probably. So score Dolphins, if it's greater than score koalas, then log to the console Dolphins win the trophy. And we can get fancy here with some emoji. Let's see if we got one. Ah, that's the one I'm looking for. But of course, once more, you don't need to worry about this part. Let's just copy this for the next one. So else, and actually we are going to use an else if because of the draw. But let's talk about that one later. So if the score of the koalas is greater than score Dolphins, then we're going to print the opposite, so that koalas win the trophy. And finally, else if score Dolphins is equal to score koalas, then we can simply say that no one wins the trophy, or actually both win the trophy. Okay, so let's test that. And indeed, we get that the Dolphins win the trophy. And that's because, as we know, this value is greater. And so actually this first condition here turns out to be true right away. And so this block of code here gets executed. Now let's just quickly increase the score of the koalas here. Let's say 100, just to see if the second part also works. And indeed, now the koalas win the trophy. Okay, but let's put it back here. And here you could have actually done it in another way. So you could have done score Dolphins less than score koalas. So basically write the same as here, but instead of the greater, you would have used the less than. So that's the exact same thing, and both are equally valid. Then here in the last part, actually we wouldn't even have needed this part, so that the score of Dolphins is equal to score of koalas, because that's actually the only scenario that's left given these previous two conditions. So basically, if none of these here were true, really the only thing possible would be that they had the same score. And so a simple else block would have been enough here. But anyway, this works just fine too. And so again, what matters is that you made it work, even if you did some things differently. For example, you could have stored the conditions in separate Boolean variables, or you could have structured the if-else statement in some different way. But if you got the same result that we just saw here, then congratulations. That's a great work. Well done, really. So maybe you even made it to bonus number 1 and 2. And so let me solve them here now as well. So let's start by calculating the average. So this is going to be bonus 1. And yeah, let's copy this one too. Let's copy this one. Let's copy this one. So I should have done it all in one go so that we can now comment out this first part. So for test number 1, this should be 97. Then the second one should be 112 and 101. And for the koalas, we have 109, 95, and 123. Let's just quickly test. And so right now the koalas win the trophy. So for now, everything works the same. But now we need to include this important condition here, which is that with this rule, a team only wins if it has a higher score than the other team, which we already have, and at the same time a score of at least 100 points. Okay, easy enough. So in this case, the Dolphins win. Okay, but now we also need to ensure that the Dolphins have a score higher or equal 100. So let's just say that. So Dolphins need to have a higher score than koalas, and score Dolphins needs to be greater or equal 100. And that's it. That's all we need for this requirement. And then the same thing here. So this is the scenario where the koalas win. So for the koalas to win, they need to have a higher score than the Dolphins, and at the same time, they need to have at least 100 points. So just like before, greater or equal 100. And so once more, we used a logical operator here to model this situation, essentially. Okay, and actually, I think with this, we implemented this bonus number 1. So let's try that again. And right now, of course, it still works because both have a score higher than 100. But let's change that now here, according to test data 2, to 106. So 106. And now they both win the trophy. So let's actually decrease all of these points like by 20. So let's make it 81 and 86. So the average should still be the same now. Yeah, but they're both below 100 now. And so this brings us to bonus number 2 that says that the minimum score should also apply to a draw. So a draw only happens when both teams have the same score and both a score greater or equal 100 points. Okay, and otherwise no team wins the trophy. So that's important too. So let's translate that. So to be a draw, the score needs to be the same, which we already have, and the score of Dolphins needs to be greater or equal 100, and the score of koalas needs to be greater or equal 100. Okay, and else, well, then we can say that no one wins the trophy. And let's just add some sad emoji here. Okay, let's try that. And now we get that no one wins the trophy. Okay, so that's because their scores are now below 100. And so we actually entered this last case here. But if we go back to the averages that we had before, so 106 and 101, let's see. And now both win the trophy because they have the same amount of points and they both have a number of points above 100. And so that's exactly what we have here. So same points, Dolphins have over or at least 100 points, and koalas have at least 100 points. And so in this case, both win the trophy. Finally, let's also test the scenario in which both have below, but the dolphins have a little bit more. Let's put this one here at 80. And so now we see that the dolphins have 96 points and the koalas have 84, but still no one wins the trophy. And that's because the dolphins have more than the koalas. So this part of the requirement is true, but they do not have over 100. So this part here is false, okay? And so true, this first part here is true, and the second part is false. And true and false gives false. And so then all of these are skipped because they're also obviously false. And so we go straight to this last block. And so no one wins the trophy, which is exactly what we were expecting as a result here. Okay. Now, if you didn't manage to do this here, again, don't worry, because I know that this is a little bit complicated already. And so in case you managed to successfully complete this challenge, then a huge congratulations to you. Well done. But if for some reason you were not able to complete the challenge, then don't worry all too much about it. You can always go back to the lectures where we first learned about these topics, and you can, of course, after this video, also review the code a little bit more carefully to make sure 100% that you understand, especially this last example that we just worked on. Okay? But anyway, great job in completing this challenge, and now I see you in the next video.